Ladies and gentlemen, welcome to my shop. Welcome to my channel. My name's Keith and I'm your host. Come on in. Let's see what our next video is all about. Okay, hey, we set up a new phone to control our Osmos camera, and then I can have the microphone on here, and we're going to get back to at least being able to talk while I have everything running, and hopefully it'll increase or better the quality of videos for you. Today we got our stern tube back to finish up, facing off the ends, drilling and putting our two stainless steel helicoils for the set screws to dimple in the bearings, and we have the bearings, we're going to put those in. And we'll talk about our threading process and things like that, which all of my older previous videos actually cover in detail most of the questions that I'm asked lately, because I get new viewers that aren't checking out my old material or haven't watched my old material, and these are questions that I've answered in the last 760 videos I've made. Just for a couple of the short questions that were made in the last video of turning the glass tube. Stern tubes are made up for fiberglass boats in this fashion. This tube comes in a bulk size and in a rough form. It's a special made tube with IDs undersized and ODs oversized. The wrapping on it is a design in a composite of material to create the strongest strength in both directions of being snapped or twisted. And it's made to modify fiberglass vessels. Typically, fiberglass vessels are laid up and they have a keel that's open, an open keel, and you have a stern bearing at the ass end of the keel with a bronze insert and a bearing, and then inside where it enters the engine room area, there's a bronze packing gland or snout for a dripless, but that's usually mounted in there. And then your keel is actually full of dead water. It really doesn't go anywhere. It fluctuates a little bit with when you're underway and when you're not underway. By inserting a stern tube into the glass boat, you're able to put one straight shot through from the engine room to the open water. And in doing so, you can insert a bearing up by the packing area and a bearing at the stern where it normally goes out the back. You usually run a dripless or a log with force water into it, so that you're running a positive flow of water from inside to outside. That keeps the dead water out, and there's not an open cavity of water that is sloshing around in your keel. And that's the main reasoning for putting this in place. Most of the time you go through this effort when you're doing a repower or changing engine locations and stringers and stuff like that. This allows you to modify for that reason. Be just shaft angle, shaft position, things like that. So that's why stern tubes are used, and that's what we're prepping here. This is a repower, and we're changing shaft size and position. Second question that kind of sticks out of the ordinary of other questions that were asked during this job was, how do we know where we were when we were center with our material, and how do we know this alignment and everything else is straight in line with my setup? Well, first off, I did do a video that actually shows this material, this jig. There's 2 pins that line up with the center slot right here, right snug as need be to hold it center line every single time. And this box and this V and all of this was all fabricated to be straight in line with the table on a repeatable. All I gotta do is throw it up here, put the 4 bolts in, it's automatically aligned. Okay, so in the design, I designed it so you didn't have to think about that, it's just automatic. Now, how do I know where I'm at as far as center with the chuck and this? And I have this old broken off 3/16 double-ended end mill, and I just lightly put it in there like that, and I bring this over to here. I release all my brakes and everything else so that I really have a real nice loose feel here, and I crank this up, and this end mill and that radius down in the bottom there are a match. And I bring that right up there like that. I don't get no motion, and I lock the in and out, and then I take and I loosen my handle so that we're not causing any direction in or out on that. Now we are aligned perfectly this direction, and then after that, then I work this direction on the part itself. If I was coming up and I was doing a rudder, I would have that laid out at both ends of the rudder, and I'd come in with a pointer and I would center point the position on that rudder. And then when I flip at 180, it automatically aligns that rudder pintle and rudder post. Alright, I'm getting set up here to face the tube. And this inner one here was almost a 1/4 inch off and on, so you could, there's a stick out here and a recess in there, so we're probably going to take a good 1/8 of an inch off of this thing, probably just to get down where we're close, maybe 3/16 of an inch to finish it off. I've taken a high-speed, a carbide brazed tool bit, stuck it in here, tighten this down here, and then we can adjust this in and out until we get to the right diameter. This is a facing and boring head, so I've got it set up for facing now. You push this plunger in here and loosen up the gibs, these 2 here, and then when you grab this ring when it's spinning, it feeds out. I've already made a pre-run because I needed to see which way it was going to face out. I know it's coming this way here, so I knew what that I needed to run a right hand tool bit in it. So that's what I have in here, and I think we're ready to go ahead and make a first cut pass here. And I'm just kind of going around determining about where I want to be. I think that's gonna be pretty close to a full sweep of cut. I might be a little bit light on the inside right here, but it should sweep the rest of this off of here. I'm gonna go get a rag. I'm gonna get a couple sheets of aluminum to fit in here. I'm gonna put the vacuum on the other end so most of it will suck in that way, and I'm just gonna turn it real slow so I'm not flying a whole bunch of fiberglass debris around, because one, I don't like to get it on my hands, The worst spot is in between your little fingers there, right in that little crease right there. You get a piece in there, it'll irritate you. The easiest way I've found to get rid of that is to take a piece of shipping tape, put it backwards on your hand, and go in here, and the shipping tape will actually pull out the fibers 99.9% of the time. It's a pretty good little trick. Alright, back to our project here. Let me finish getting set up here. Okay, let's see what we got here. Okay, I like to kind of hold this ring before it gets going here. There we go. That vacuum's really working good. There's virtually nothing coming outside here, just about. We probably could have done this in one pass. Alright, that's pretty good. One little hollow right there, from there to there. We'll just take another pass, we'll crank it in. Okay, push the pin back in to lock it. Alright, lock down the table. I think that's going to do her. We'll know at the first when we touch off. If not, we'll back it in there and we'll take a little bit more. But okay, that looks like it's going to clean up 100% right now. Okay, this can come off with just a file and just a little bit of a sanding on that edge right there. That'll break that. So I'm going to go ahead and back off and then endo the tube, and we'll set up on the other side. We'll have a little bit of a height difference because this OD setting in the V. We'll just lower it down a little bit and we'll be able to do the same thing on the other side. Alright, after machining both ends here, we're ready to go ahead and drill for our helicoils. We're going to put 3/8 inch helicoils in here, and we're going to put 2 short ones in on this end, and then the other end there we'll be able to put 2 medium lengths. My favorite way to lay this out is leave it in one position here, take my center finder and leave my square at the top with the level, and I go ahead, level that out, give myself 2 lines straight across. Now I'm going to go to the other end and do the same thing. Okay, after we have those lines, we can take the center finder or edge or center head, and we can go ahead and take our square now. I'm going to shorten it up here so I'm not hanging up on that end over there. Okay, like this. Now we can square off this face here We can roll it over, and we can do the same thing on the other side. Now we can decide how far we want to go in on each of these. We'll go mark the other side, and that's where we're going to put them. Okay, I think we're close enough. I need to get my crescent wrench here so we can lower this down a little bit. Okay, it normally is always up here, and for some reason I was using it somewhere else. I like to come down about like that when I'm getting ready, because my handle is in the right position to start the hole right there. All right, and all right, within a 1/16 of an inch of that cross line. Okay, grab the vacuum. Okay, we're running a medium length here, and we're going to try to subset it into the glass so it's not protruding down through the bottom and it's down below the outside surface here. And this is so it doesn't wear out the glass. Okay, I just saw it disappear from there, and I'm gonna have to get the flashlight and look in there. Don't mind my big head here. Okay. I like to make sure that I have it down close to there, and doesn't hurt to have it in a little bit from there. All right, I'm happy with that depth there. All right, now we'll knock off the tang. I like that. When you loan out sets, important parts don't always come back. Okay, if that ever happens to you, like it just happened to me, that I loan out something and not all of it comes back, and you happen to be missing your your knockout pin. All you need to do is grab your transfer punch, and you just want to get to the one down below 5/16. That'll give you clearance to the root, and then you'll have it just the right size, and then that tang should be laying down there in the bottom of the oh, and it is. It's in there quite a ways. There it is right there. Alright, roll it over and we'll do the other side. Alright, I get asked more and more often about threading bearings. There've been a lot of conversations about threading bearings, and the reason why you thread a bearing is so that you can pull the bearing out using the threads that you cut on it. Now, if you take a magnifying glass and you look real close, you can see that the crown or the OD of the thread is left the natural diameter or the true diameter of the cutlass bearing, so that the integrity of the press fit, even in this threaded area, is making contact with your bore and is supporting the bearing the way it's supposed to be. Alright, now the only difference about how you put these in is how much you leave sticking out. And I manufacture these nuts. These nuts are specially manufactured to be oversized for every bearing diameter. I have a handful of collections because there's quite a few guys here on the Cape that use this technique and this system, and I hang on to the nuts and the wrenches. They know where they're at. When they get, every 3 years, when they replace their bearings like they should be, they bring it they come to me, they borrow the nut, they draw it out, and I get the new bearing for them, or they bring it in and then I thread it, and I thread it for the nut, so that this bearing is ready to install in their shaft again. Alright, so this is an ease. Also too, with this system, you can pull out your bearings with your shaft in place. You do not have to pull out your shaft to pull these bearings out. Okay, so what I do to put these in is I screw it flush with the surface, and that's the amount of stick out that we're going to let go on here. Alright, and then I insert this in here and tap it in. Alright, then we unscrew it. That is the amount of stick out. Now we will drill and dimple both set screws on both sides. And we'll install the set screws, and this bearing is in its final resting spot. Everything else will be gauged off of that. This thread right here, when you're ready to go, you take any marine growth or anything that's on it, you wire wheel it off of there. You come borrow the nut, you screw the nut on, and I have the spanner wrenches that go over the outside of this and use to draw it back out. If you get it out so far and it still needs to be drawn out more, we supply a sleeve that slides over this, and then this nut will ride onto the sleeve and finish pulling it out like a puller extension. Alright, and that's the facts about threaded bearings, and that's as simple as it is. Everything that I need to do to this stern tube or shaft log is done. My job was just to get 2 bearing bores, get the diameter built up here, and install the bearings. Now they're going to go ahead and they're going to take it down there and they'll install it. They'll have to glass it in place and bond it to the hull. Alright, now I have other projects going on down there on the vessel, and sometime or another I'll get down there and I'll see what I can do about getting a couple pictures of this in place. At least I'll be able to show you what it looks like sticking out the ass end, and what it might be coming up into the engine room, how it looks at that end as well. All right. Hope that answers some questions about shaft logs, stern tubes, and glass tubes as in general. And until next time, get her done.